Hello, welcome to my YouTube channel Kiwi Bushcraft and Survival. I'm Glenn Vickery, and today I thought we'd go on to the next video for the land navigation videos. So today I thought we'd talk about the 3 north points. Technically there's 4 north points, but we're going to talk about the three main ones today, and I'll briefly discuss the 4th one at some point so you know what it is. Now the north points in navigation, are very important. If you don't have an understanding about the north points right from the beginning, you'll be completely lost as far as when it comes around to doing the navigation. Okay, so it's really important that we get through these and that you understand them fully, so that you'll be able to do your navigation properly. Okay, so let's get into it. Okay, so the first north point, in fact before we even get into the north points, I want to do something like this, what we call a compass rose. Okay, so you have north there. Let's put this up the top, eh? We'd have north there, okay, for N, okay, north. Okay, then we'd have, like, let's say we have an arrow there. Okay, and then over to the right hand side we would have east, okay, or E, east, right, and then below that we would have an S for south, okay, and to the left of that we would have a W, okay, which is for west. Okay, now this is basically what we call a compass rose. Okay, a compass, let's write that over here somewhere, that you can see it. If you can see at the top, I might have to move the thing up. I'll move this camera up just a little bit to make sure we get that in. Okay, and we call it a compass rose. Alright, as in like a flower, a compass rose. Alright, now that's very important that we understand these points. So always north at the top, east is out to the right, south is down the bottom, and west is out to the left. Now how can we remember this? Okay, what I'm going to do is I'm just going to get rid of the words for the north there and just leave the N there. Get rid of that and just leave the E. Get rid of that and just leave the S. And get rid of that and keep the W. Okay, so how do we remember this? What we do is, this is an easy way to remember it. We go never, and then we go to the right, okay, as in clockwise, okay. So clockwise is always going in this direction, like that, okay, always going around that way, clockwise. The way a clock goes around to the right hand side, alright, like so. So it starts off at 12 o'clock, then it goes to 1, okay, 2, 3, 4, 5, 6, it goes clockwise. So that's all, clock is always going around. So we go never for the N, eat for the E. Oh, see if I can remember how to do this. Sausages. Sausages. I might be writing that wrong. Sausages, S, okay, sausages, and W is wet. Alright? Never eat sausages wet. Now there's other terminologies or sayings that people use. Never eat soggy wheat bix, okay, is another one. I just like to use never eat sausages wet, okay. Always cook them first. Make sure they're hot and dry, okay, so to speak. Alright, so that's an easy way to remember the compass rose as far as the basic points on a compass, okay. And then of course in between these we would have out to here, we would have northeast. Down in between east and south we would have southeast, and down this way we would have southwest, and then up this way in between west and north we would have northwest. Okay, so you don't really need to remember these other ones, and it can get you can split these up even more if you wish to, but the main ones is north, east, south and west. Remembering the term, never eat sausages wet. Okay, so that's the compass rose. Now a compass rose, although we're doing it on a board here, and north, we're doing north here pointing up, okay. Now north doesn't point up towards the ceiling, okay, and south doesn't point down. So north doesn't point up towards the ceiling or up towards the stars, and south doesn't point down towards the ground or to into the middle of the planet, okay, into the earth. The compass rose here is just to get an idea of understanding direction between north, east, south and west. Now if we were actually standing somewhere, let's say this is a person standing on the earth, okay, now here's him standing on the earth, okay, if he was looking in a northerly direction, north might be out that way, okay, which means east would be out in this direction, okay, east, and then of course south would be out in this direction, and of course west would be out in that direction, okay. So there's our thing, never eat sausages wet, okay, and obviously he would be doing this on the land, okay. So the compass rose, when we do the compass rose and we're pointing it north, okay, technically the compass, a compass or a north direction is not actually pointing up towards the stars. It's actually pointing in the direction that we're walking on the planet, okay, on the earth, alright. So in other words, it's horizontal, okay, when we're standing on the earth, okay. So that's very important that we discuss that before we even talk about the north points. So what we're going to be doing is now discussing getting into the 3 different north points so that you can get a better understanding of navigation. So the first north point, okay, let's do our number 1 here, is what we call true north. Okay, true north. Otherwise, sometimes seen, and I'm going to put it in brackets, as TN. Okay, TN for true north. And that's the abbreviation, okay, and the symbol, there's a symbol normally that's used for true north, and the normal symbol is a star. Hopefully my star turns out, alright, like so, alright. So there's our star. So that's the symbol for true north. Okay, and normally that star will have a line like that on it, and that would be saying that is true north, that star, that point there. Okay, so don't get too flustered about that just yet, okay, because it'll all come and make sense as we get into it. Okay, so that's the first north point, and that's the first one we're going to be talking about. But before we start talking about that, I want to talk about the other north points. The second north point, okay, is a very simple north point. Let's just go back to true north, okay, firstly, and I'm going to explain it very basically, true north, okay, to you. So true north, let's imagine this is our planet here, okay, and we'll get it up the right way. Here's Australia. It's not where I live. I actually live down here in a little place called New Zealand, okay, so Australia, New Zealand. Okay, so true north is, I'll just spin the globe around so you might be able to see where your country is, so you can orientate yourself. All right, so here's Africa, all right, coming over to South America, and North America up here, okay, still cruising around, all right, and into Australia. Where are we up here? Great Britain, or United Kingdom, okay, and so on and whatnot. Okay, so most of us know the planet as we see it like this, okay, and the true north, okay, is up the top of the globe here, where my finger's pointing, okay. True north is up here. True north is where the North Pole is, okay, the North Pole. Basically, you might understand that as where Santa Claus lives, okay, up where all the ice is up the top here, top of the planet, okay, north. Now, and then obviously the south, so that's where true north is, and true south is down the bottom of the planet, down here, okay, all right, where the South Pole is, which is under here, okay, that's true, what we would call true south. So true south and true north is at the top, okay, and all the meridian lines that you can see coming from, say, true north here, see all the lines coming down here, okay, all those meridian lines there, they join up from the South Pole and they go all the way up to the North Pole, okay. Now you can see here that these meridian lines, they're very close together as they come towards the North Pole, and as they come out they spread out and they get bigger towards until they get to the equator, and when they get to the equator they are then parallel, okay, and they're even, alright, as they go right around the equator they're even, these meridian lines, okay. And then as they carry on, these meridian lines, we've got one on each finger here, as they carry on they'll get closer and closer and closer together, all right, until they end up touching at the bottom of the planet, which is the South Pole, or otherwise known as true south, okay, true south. And at the top of the planet we have true north, okay. So where you see these meridian lines splitting, getting closer and closer together here at the top of the map, they're close apart, and then as they spread out they become bigger, If we go to, you can imagine when maps are done, okay, the maps are not going to be exactly correct, okay, because the maps are going to also point towards north. But anyway, I'm going to get into that later. Okay, so that's true north, where Santa Claus is, okay, or on the ice, okay. Right, so the other north, let's get back to this. The other north is called, and I'm going to talk about grid north more, okay, but the other north is called grid north. Okay, grid north. And grid north is, as you might guess, abbreviated with, I could do my G a little better, GN. Okay, is the abbreviation, GN. And the symbol for grid north, I'll just rub this one here out a little bit up there. The symbol for grid north is a box, normally a box. Okay, now what's really important before I carry on is the symbol for true north is normally a star. Okay, sometimes they might do a double arrow, okay, sometimes they might do something else, but normally it is a star. Okay, and sometimes they might just write TN. Okay, for grid north, normally it is a box, a square box, and sometimes they'll write GN, but they may change it. Sometimes they just have a line. Okay, all right, and that would normally have a line on it as well, saying that it's pointing towards grid north. Okay, and again we'll get into that another time. Now basically, grid north, and I've sort of spoken this about to use on my other videos, okay, grid north is to do with, so true north is to do with the planet, okay, pointing to the North Pole and the South Pole. Grid north is just talking about the maps, okay, when you're dealing with a map. And grid north is, for those that have followed my last videos on navigation, we have the lines here on the map. I'll see if I can get it a bit closer. The grid lines on the map here that are going straight up and down, okay, those are what we call the eastings, okay. Now the eastings that are going straight up and down in the direction of my pen here, at the top of the map, okay, the grid lines that are pointing north, that are pointing to the top of the map, that's pointing towards grid north, okay. So the top of the map, as these lines go up, they're pointing towards grid north, okay. And as the lines point down to the bottom of the map, that's pointing towards grid south. Okay, so when we talk about grid north, we're just talking about the grid lines that are on the map that are pointing to north, and if we're talking about grid south, it'll be talking about the grid lines that are pointing towards the bottom of the map. And if we're talking about grid east, okay, which we don't normally, that would be pointing to the east, okay. And let me just look at the map. Yep, east, okay, going this way, and west going this way, okay. So, but you don't need to worry about grid south and blah blah blah. All you need to worry about is grid north, knowing that grid north is at the top of the map, okay, wherever these lines here point, okay. And you might think, oh, okay, but what if I point my map in whatever direction? Is that grid north? Yes, that's grid north, okay, but you won't end up just pointing your map in any direction. We will link grid north up to the other north directions, so that the map will be pointing in the correct direction. Okay, so we'll use true north, or we'll use magnetic north, which is the next one we're going to get into, to help us to point our map of grid north in the correct direction, so that we're reading our map the right way. Okay, so and that will come more when we get into the actual practical side of using the map with the other north points. Okay, so grid north is just simply when we're using the map and the grid north points to the top of the map. Okay. And that's for all maps. All maps have a grid north. Okay, they all have a north point pointing to the top of the map. Okay, so the next one we're going to talk about is the next north point is called magnetic north. Magnetic north. Magnetic north. Okay, and that's abbreviated obviously with a MN. Okay, MN, or Mike November. And magnetic north is normally abbreviated with an arrow. Okay, it's normally with a, I'll try and get this arrow right, it's normally with a half arrow, like so. And that would normally come down like that. Okay, so it's normally done with a half arrow. If the arrow is on that side of the on the eastern side, or the right hand side, okay, of this line, that arrow there is on the right hand side, or the eastern side of this line, that means that the magnetic north is giving us what we would call an easterly declination. Okay, but we're not going to get into that right now. I just want you to understand that this is talking about what we'd call an easterly declination, which is okay. And if you might also see one that looks like this. Okay, sort of looks like that. So it could look like that. Okay, and if it's on the left hand side, that's normally telling us that the magnetic north has a westerly declination. It's on the left hand side of the this line here. Okay, so it could be on the left or right. Okay, and that's the normal symbol for magnetic north. Okay, now it could vary as well. Some people, you'll see some things where they'll have a double arrow on it, and or it might have the MN, okay, the MN at the top of it, signifying that that's magnetic north. Okay, so these are the normal symbols that you'll see, but they can vary. Just be aware of that. Now, magnetic north. What is magnetic north? Again, true north is at the top of the planet, where Santa Claus lives, in the ice. Okay, the North Pole. Okay, grid north is the top of the map. The grid lines, okay, the grid lines, or the easterly lines that are pointing to the top of the map. All right, the lines that go vertical, the ones that are pointing up. Okay, that's grid north. Those lines pointing up are pointing to grid north, the top of the map. Magnetic north is, and this is only used for maps, and this one here is used for compasses. Okay, all right, this one here is used for compasses. So what I'm going to do in red, all right, true north is to do with the planet. Okay, or let's just say the globe. All right, the globe. Right? Grid north is to do with the map or maps, okay? And magnetic north is to do with compass. Alright, compasses. Okay. So, magnetic north is to do with compasses, okay? So, let's have a look. Here's an old compass, okay, of mine. My favourite, one of my favourites, okay. Now, when I open it up, if I was to, I'm going to see if I can get this, I'm going to see if I can get this onto camera. Now, I don't know if it will or not. Okay. Now, where is it pointing to north? Okay, do I have a pen on me? Let me just pause it and see if I can get a pen. Hang on. Okay, I've got a pen. Alright, so the compass on this one here, you can see here, that line there, that's north. Okay, so if I point this compass around that way, it is now facing north. And you can see on our compass rose, out to the right is east, and down to the south here, the S is south, and out to the left here is west. So this compass is pointing, the north point is pointing north, okay? Alright, and so that's how we find magnetic north. We use a compass to find, a compass points to magnetic north. Alright. Let me get out another compass of mine. That last compass you looked at was in what we call mils. Here's another compass. Okay. As you can see here, the magnetic needle, now it might move because of the pen has metal on it. The red needle here points to magnetic north. The white needle points towards magnetic south, the opposite. Out to the east, let me just move my pen around. Out to the east here, where my pen is moving, that would be east. Okay, because if we have north, never, east, eat, south, sausages, west, and that would be out to the left there. The magnetic needle on a compass will always point to magnetic north. Okay. That compass there was in what we call degrees. Okay, it's just the measurement that we read that particular compass. Okay, so magnetic north is the direction finding north, okay, using a compass. Alright, magnetic north. Now, let me just rub this out for a second. And let's talk about a couple of basic things. We have the planet here. We have at the top here, let's do a star, and that signifies true north. TN. If we have a, and here's our lines, right? Those are meridian lines that come down like that. Alright, and they all meet up at the South Pole, down the bottom here. If we were to do a map on the planet, let's say we had a country over here somewhere, and we had a map. There's our map, our square map. Grid north. Now the map, let's do our map a little bit bigger. Let's just imagine our map was like that, okay? Just for the sake of doing our map. It would be smaller than that, obviously. Now on our map, we have grid lines, the lines that run from north to south, like that. Okay? At the top of the map, that would be, at the top of the map here, right, the top, that would be grid north. Okay, grid north at the top of the map. Okay, because these lines that run straight up and down, they always point to the top of the map. At the top of the map would be pointing north. Okay, and basically they would be pointing towards the top of the planet in that direction. Okay. Now, the third north, which is magnetic north, is around, let's imagine that it was over here. Okay, magnetic north is over here. Now, magnetic north is magnetic because let's just go back a little bit and I'll explain why that's there in a second. Basically, a compass, if we had our compass, let's say we had a compass here. Alright, there's our compass. The red needle on the compass that always points north, the red needle would be pointing there. Okay, so it would be pointing towards north, towards magnetic north. So here is magnetic north. Okay, let's do grid north would be seen as, let's just get rid of that a little bit first. Grid north would be like this with our square. Okay, looks like that. Alright, grid north. And our magnetic north would look like, it would have an arrow on one side of it. Okay. Now, the magnetic needle, as I said, the red magnetic needle always points to magnetic north. Alright, so here is magnetic north. Okay, which is here. Alright. The black other side of the needle, it could be black, it could be white. Okay, that's pointing towards the magnetic south pole, which would be in this direction. Let's just do a circle over here. Alright. Okay, but that would be pointing towards magnetic south, and the red one, the red needle on the compass, this is our compass. Okay, I'll just do our compass here. Alright, here's our compass. Compass. Alright, the compass, magnetic needle, the red one here, would be pointing in the direction of magnetic north. Okay. Now, where does this magnetic north come from? Why is it not at the same place as true north? Okay. This is how it works. Magnetic north is created from molten lava inside the planet. So inside the planet, under the ground, okay, under all the seawater, in the middle of the planet, there's molten lava or molten rock, and it's moving around in there. And that molten rock, as it's moving, it creates a magnetic field. Okay, it creates a magnetic field. And that magnetic field comes out of the Earth, planet Earth, here. Right, that's where the magnetic field comes from. Magnetic field, magnetic energy. Okay, it comes out of the planet and it goes around the planet. I'm probably going to be drawing a bit of a mess here, but it comes out. This magnetic field comes out of the out of magnetic north, and it goes around the planet, and it goes around the planet and back into the planet through magnetic south. Okay, on the other side of the planet. And that magnetic force field comes out and it goes around the planet and it comes back in. And that magnetic force field comes out of magnetic north, comes out of magnetic north, and it goes around the planet and it goes back in magnetic south. Alright? And this magnetic force field goes both ways. It's coming out here and it's going around and it's feeding back in. The magnetic force field is coming out of magnetic north here. It's going out around the planet and back in to magnetic south. And this magnetic force field that is going around our planet, okay, it looks like that. I'm trying to do the best I can. That magnetic force field protects our planet from nasty, harmful things that are out in the universe, out in space. Okay, like radiation. Radiation will try and get through and it'll bounce off this magnetic force field. So our planet Earth actually has a force field around us, protecting us, created by all that molten lava inside the planet. Okay, but it comes out at a certain point on the planet. Alright, comes out of the north and it goes in through the south. And our magnetic north needle points to that magnetic north where it comes out. Okay, and that's why our magnetic needle points there. Now, something to understand about magnetic north. This magnetic north point moves. It doesn't stay in the same place. Okay, originally, if you imagine that this here is this picture I'm doing here is Canada. Imagine this is Canada up here. Okay, I'll try and imagine that's Canada, right? And this is North America, and this is South America. No, it's not the greatest. But let's just say that this part here is Canada that I'm drawing in here. Alright? Magnetic north, which is here, used to actually be at one point around the top of northern Canada. But because molten lava is always moving, magnetic north is constantly moving. So it used to be here, right? Then it would have moved to there, right? Then it would have moved to there, right? And now it's there, okay? Now I don't know exactly where it is right now because I haven't done any research on it myself, but it's constantly moving. And every year it will move a certain distance in a certain direction, okay? So magnetic north is always moving, okay? True north stays where it is. Grid north is wherever the north is pointing on the map. Whichever direction we're pointing the map, that's where grid north is, wherever these lines are pointing on the map. Okay, so those are the three north points. Okay, in fact, just a little something extra for you, a bit of knowledge. That magnetic north there, at some point it's going to flip and it's going to become magnetic south, and magnetic south will end up becoming magnetic north. Okay, so that's going to happen at some point. It happens approximately every 2,000 years. So pretty much we're due for a magnetic flip. Okay, and if you want to learn about that, you'll need to do some research on it. My guesstimation, I think the scientists worked out, the scientists were saying it's not going to happen for at least another 1,000 years or something like that. I worked it out to being around about, just very basically, I worked it out to being around about the next, anywhere between now and 350 years. Probably anywhere between 100 years and 350 years. Okay, but it could happen any time now. Okay, will mankind die from it? No. Alright, it's happened before, it happens every 2,000 years, and mankind's been around a lot longer than 2,000 years. So, we will live through it. Okay, so that's the called the magnetic flip. Anyway, so those are the three north points. Okay, magnetic north, true north, or should I say true north, grid north, and magnetic north. Now those three north points are very important to know and to be able to understand them, so that you can, at some point we're going to use those three north points to be able to find our direction when we're doing navigation. Okay, extremely important. Now there is one other north that I said I was going to talk to you about, and that's called celestial north. Okay, and that's basically when we use celestial north. Celestial means stars. Okay, up in the sky, the in the universe there, celestial. Okay, it's just a flash name for saying up there in the stars. Celestial north is just using the stars, the sun, the moon, to find north. Okay, using those stars and everything from above, looking above us, using those things above us to find north. Now, celestial north, when we use the stars, the moon, and whatnot, and the sun, when we find north using those, it's only about a couple of degrees off true north. Okay, so the celestial north point, when we use, it's really hard to explain. When we find north using the stars, that would be celestial north. Now, celestial north is only a couple of degrees off true north. So we can use the stars, the moon, and the sun to just find north. Okay, and most of the time, well, not most of the time, all of the time, we just generally see that as finding true north, because it's only a couple of degrees off. It's not worth confusing ourselves with another north. Okay, celestial north, using the stars and everything, is only a couple of degrees off true north. So we just say we're using the stars to find true north. We're using the sun to find true north. We're using the moon to find true north. Technically, it's celestial north. It's a couple of degrees off true north, but it's only a couple of degrees. It doesn't matter. We just call it true north. Okay, so all the maps that we use have true north, may have true north written on them. Everything's done normally with true north because it's an actual physical point on the planet. So we generally use the stars and everything else, and when we find north from them, we generally call it true north. Okay, just something to be aware of. It's only a couple of degrees out. What is the point of finding north with true north, grid north, or magnetic north? The point in finding those is that when we find north, we can then know where east is. East is out to our right at 90 degrees. Okay, south is the opposite to north, which is at 180 degrees. And then if we're going out to the west, which is on our left-hand side, okay, of north, at, let me think, 180, 90, 320 degrees, 280. Can't remember, I'm not thinking straight. 180, 20, 200, and I can't remember. Who cares? Okay, it's out to our left. So always remember north, east, south, west. Okay, never eat sausages west. Okay, now let's go to something else really quickly when we're doing our north, east, south, west with the compass rose. Okay, now when we use the compass rose, we had our north here, our east, okay, our east out to the right hand side, our south out here, and our west out here. I'll just grab my compass out, and the first one I'm going to do is we have two types of things. We have a thing called degrees, okay, degrees. Let's do degrees, what I was just talking about. Okay, now degrees, the symbol for degrees is a little 0. Okay, what I'm going to do is I'm going to push this north up here. I'm going to push this east out a bit. I'm going to push this south down a bit. I'm going to push this west out a bit. North can be read as, when we're talking about degrees, can be read as 0 degrees, or, let's just bring that down a bit, can be 360 degrees, okay, or 0 degrees. Alright, just see if you can see that. I'll bring that up a little bit. Oh yeah, oh yeah, you can see it, it's okay. Okay, so we've got at the top, north can be classed as 360 degrees or 0 degrees. So we're giving them numbers now, and it goes around in a clockwise direction. Okay, the numbers. So, as I said, out to our right here, we have 90 degrees. Okay, down here we have, at the south is 180 degrees. And out to the west here we have our 270 degrees. Okay, which is an extra, I don't know why I didn't figure that out before. It's only another 90. I couldn't, my maths was just going all over the place. Too many things going through my mind. In between these, okay, so that's going in a direction like that. So if we said we're going to head on a, so here it goes 0 to 90 to 180 to 270 to 360. So north can be called 360 degrees, or 360 degrees, or 360 degrees, or 0 degrees. It doesn't really matter. Okay? Or we could just say north. These are all optional. In between the 0 degrees and the 90 degrees, half of that, which we would have our, normally up here, our northeast, okay, would be 45 degrees. Half of 90 and 180 would be, just trying to look at my compass, 125, I think, 125, let me just count it. 90 plus 45 is 5, 8, or 9, 10, 11, 12, 13. Be 135 degrees, okay, which is southeast. Okay, and then to go up here, going up here, which is halfway between 180 and 270, would be our southwest. We add an extra 45 on, so that would make it 225 degrees in that direction. If we're heading in that direction, it would be 225 degrees. And if we're heading in this direction, that would be northwest, a northwesterly direction or northwest direction. And we add an extra 45 onto here. So that would be what? 5, 10, 11, carry the 1, 315. 315 degrees, okay, which is northwest. Alright, so that's how we would use the compass that I was showing you earlier, which is in degrees. This is read in degrees. And so I'm not going to be doing compasses right now, but using this dial here, okay, we can find the direction we want to travel, or that we're traveling in, through the numbers here. The next one that we would use, okay, now degrees for a compass, rows, or for on a compass, is used by a lot of civilians, okay, but it's also used by military, especially okay, so as I was saying, the US military, United States military also use the degrees, okay, and there's obviously other defence forces out there that use degrees. The other one that's used, and you would have seen that on my other compass, is what we use for the what we call mils. Okay, mils. And mils is just another method of numbering system that we use for a compass. Okay, and with north we have either again 0 or start it here. We have 0 or 6400. So it's 6400 mils, okay, or 0 mils. Right. We don't normally write the mils in, but I'm just doing that just to emphasize it. Out to the right hand side, it go from 0, and we go clockwise, but for east we're looking at 1600 mils. For the south we're looking at half of the 6400, so we're looking at 3200 mils or 3200 mils. Okay, and out to the west here we're looking at 4800 mils, okay, or 4,800 mils. Alright, and then of course it would come back up and it would finish off at 6,400 mils, okay, which is the same as a 0 mils. It's you can use whatever you want, but normally we would say 6,400, knowing that we're heading north, okay. And so obviously I'm not going to do this one in the middle, but in between 0 and 1600 would be the middle of that, which would in this case would be 5, 6, 7, 8, 800 mils. Okay, I don't want to do all my math. Well, it's simple really. If 800 mils is northeast, another 800 on here would be 2,400. To confirm that, another 800 would be 3,200, and another 800 there would be 4,000 mils. Might as well whack them out for southwest. and another 800 mils on top of 480, or 800 would be 5600. Okay, so mils. Alright, so that's how we do the mils system. Now, just real quickly, I know it doesn't have anything to do with north now as such, but why do we use mils? Some militaries use mils, some use degrees. Mils is just seen as more accurate. Okay, you can basically, you've got a lot more numbers in between, say in between 0 and 800 here, you have a lot more numbers than you would with 0 to 45 degrees when we're talking about degrees. So from 0 to here would be 45 degrees. With mils it goes from 0 to 800. So we've got a lot more numbers in between this space here, which means there's going to be, we can get our needle, or not our needle, but yeah, our needle, okay, on a number, and it can be a lot more accurate. Okay, so the accuracy increases using mils, and all we're doing is just using another number system that has more numbers in this circle, right? This clock circle here, all right, and the compass rose, so to speak. We have a lot more numbers, which means we can get the needle a lot more accurate on a specific number, which means our accuracy in navigation goes up. Okay, so that's all it is. There's two different systems. But the whole idea of the compass rose is to get our north. If we get our north point, we can get our south, our east, our west, our northeast, our southwest, and so on. Okay, and that's what it's all about. Okay, so I hope that there, I know it's a little bit long, but what we'll do on the next video is I'm going to focus on true north. Okay, I'll focus on true north. And what I'm going to do with true north is I'm going to teach you some ways of finding true north. And I'll be basing it on the southern hemisphere. However, all you have to do is do the exact opposite to what I'm basically teaching you, and you should be able, and well, do exactly the same, should I say, and switch it around. So when we're finding north using those techniques, you'll technically be finding south using those same techniques that I show you. Okay, or you may have to modify it slightly. But if you can find south, then you can find north. Okay, so that's what we're going to be doing. That'll be quite a good video. So we'll be talking about using celestial navigation mainly, okay, to be able to find true north. It's very, very important that we can find north using the stars, the sun, the moon, and by using those we can use other methods from those to be able to find north. And if we can find true north, then we can find magnetic north without a compass. We don't technically need a compass if we can find true north. Grid north is easy. It's on the top of a map. Okay, it's just where the top of the map is pointing. Okay, that's pretty much it for grid north. So I shall see you on the next video. I hope you enjoyed that. I hope you've learned a few things. Share, like, subscribe. I don't have any copyright on my videos, so if you wish to use them, then go for gold. I'm all about sharing the knowledge, and we all learn from each other, and we all benefit in that way. Yeah, okay. Hei kōnei rā, take care, and I'll see you next time. Cheers, bye-bye.